In Activity 11, Starlight, Star Bright, students explore stars beyond our solar system. Students first discuss the distances of stars from Earth and one another in terms of light years, and then discover that stars differ in size and temperature. Finally, students discuss and explore the concepts of galaxy and universe. You'll need the following materials from the kit: Activity Sheet 11, D batteries, flashlights, pen lights, meter stick, and a roll of masking tape. You'll also need to provide solar system model from Activity 10, 8.5 by 11-inch sheet of paper, and a pair of scissors. To prepare for the activity, make a copy of Activity Sheet 11 for each student. Then insert 2 AA-size batteries into each pen light and 2 D-size batteries into each flashlight. Finally, cut small pieces of white paper and tape them over the face of each pen light and flashlight. To begin the activity, review the terms star, sun, and solar system with the class. Remind them that our sun is a star, and all its satellites make up our solar system. Next, introduce the 2 stars, the North Star and Alpha Centauri, which will be discussed in this activity. Some students may already be familiar with the North Star, also known as Polaris. Review the term axis, which students know as the imaginary line through the center of Earth. Then ask, what are points at the ends of the axis called? Students should identify these points as the North and South Poles. Explain that the North Star got its name because the axis at the North Pole points towards that star. Inform the class that travelers have used the North Star for centuries as a guide in their journeys across land and oceans. Next, tell students that our star, the Sun, is a great distance from Earth, but that the next closest star is 272 times that distance from Earth. Then guide students to learn that the distance between the Earth and the Sun is 149,600,000 kilometers, and the distance Earth to Alpha Centauri is 40,678,000,000 kilometers. Note that Alpha Centauri is actually 3 stars, so closely related to one another that we refer to them as though they were a single star. Point to the classroom model of the solar system and ask students, what is the scaled distance from the Sun to Neptune? If students do not recall the scaled difference, have a volunteer measure it on the classroom model using a meter stick. Inform students that using the same scale, a model of the North Star would have to be positioned out in space, about 10 times as far away as our moon. Introduce the term light year to the class as the distance that light travels in 1 year, and that a light year is equal to 9.46 trillion kilometers. Because stars are so far away from the Earth, astronomers use this special unit to describe the distances between stars and other objects. Next, tell students that light leaving our Sun right now will not reach Earth for 8 minutes, and that light leaving Alpha Centauri will not reach Earth for 4.3 years. Explain further that light leaving the North Star right now will not reach Earth for 300 years. Ask students, of all the stars you can see in the night sky, do you think the brightest stars are the closest stars to Earth? Accept all speculations, then introduce the term relative brightness to the class as whether one light is brighter than another light. Then have 2 students measure the classroom with a meter stick from one wall to the opposite wall. Divide the measurement by 2 to find the halfway point, and measure and mark that distance with a strip of masking tape. Next, distribute Activity Sheet 11. Group teams of 4 along one wall of the classroom and distribute the flashlights and pen lights to the teams. Instruct the members of each team holding pen lights to go to the opposite wall, stand side by side, and face their teammates. Darken the room and have students turn their lights on. Hold them steady and shine the lights towards their teammates across the room. Tell their teammates to observe the relative brightness of the 2 different lights. Next, instruct the students holding pen lights to move to the center of the room and shine their lights toward their teammates. Again, have their teammates observe the relative brightness of the 2 lights. After students have completed their observations, have them compare the brightness of the two pen lights at different distances, and then instruct teammates to swap tasks so that all students have the opportunity to hold the lights and to observe their relative brightness. Then, have students record their observations about relative brightness and complete their activity sheets. After students have completed their activity sheets, ask, "Do you think you can determine how far away a star is by how bright it is?" Students should have observed that the flashlight was brighter than the pen light, even when the flashlight was farther away. From this observation, they should answer no, that they could not determine how far away a star is by how bright it is. Explain to the class that all stars do not have the same actual brightness. A star's actual brightness depends on its size and temperature. For instance, even though the North Star is very bright in the sky, it's 300 light-years away from Earth. Next, introduce the term galaxy to the class as a massive, swirling cluster of stars. Let students know that there are countless galaxies in space and that each one consists of billions of stars. The galaxy to which our solar system belongs is called the Milky Way. Finally, introduce the term universe to the class and explain that a universe consists of all the galaxies and the other matter and space that surrounds them. To help students visualize the relationship between the universe, the galaxies, the stars, the planets, and the moons, refer to Figure 11.3. To conclude the activity, remove the batteries from the pen lights and flashlights and return all materials to the kit. For science background, reinforcement activities, curriculum connections, and information about the Delta Science Reader, please consult your DSM Teacher's Guide.